All right, the Chapter 6 test will come in two parts. The first part that you will take is the non-graphing calculator part, and then the other second day will be the graphing calculator part. On the first part, you're going to have to solve a system of equations. One question will have two unknowns, another one will have three unknowns. You will have to graph the feasible region and find the minimum or maximum value based on what the equations are, and then questions from previous materials. If you want to look back at the Chapter 5 review online, you could do that. There's going to be some questions from that chapter on there. Also, some of the problems that you did in the Chapter 6 review, the ones after number 10, there will be some questions similar to those as well. On the calculator part, solve systems by any method, solve a system from a question, create a transition diagram, and maximize or minimize a product. And then questions from previous chapters as well. Same thing there. This first video will only deal with the non-graphing calculator part. Video 2 will deal with the graphing calculator part. So solving a system of equations. Here we have two equations with two unknowns. You can solve this by substitution or elimination, and so we're going to multiply that one by a -2 and use the elimination method. And when you multiply by a -2, you would get a -4x minus 10y equals a -32. And then adding these together, that's 0. -12y equals a -24. Divide by a -12, and y is equal to 2. Once you have y equaling 2, we can substitute that into any one of the equations we have previously to find x, and we are going to choose the 2x equation. Plus 5 times 2 equals 16. And then we would multiply by 5 and 2 to get 10. So 2x plus 10 equals 16. Subtract 10. And 2x is going to equal 6. Divide by 2. And x will equal 3. So our solution is x equals 3 and y equals 2. And then don't forget that if in your equation you get to the point and you add them together and you get something like 0 equals 7, this would be no solution. And if you came down and did all of this and got something like 3 equals 3, this would be infinite solutions. Because 3 equals 3 is a true statement, whereas 0 equals 7 is not a true statement. Then solving 3 equations with 3 unknowns. And first thing you have to do is try to get it down to 2 equations with 2 unknowns. We got to eliminate a variable. Which one you choose to eliminate is completely up to you. Let's see, because we have this one being just x by itself, we're going to choose to eliminate the x value. So if we first multiply this by a -2, and then combine it with that equation, so that one we are going to just rewrite. And then multiplying this one by a -2, we will get a -2x plus 10y minus 4z equals a -84. Combine them and you will get 13y minus 10z equals a -60. Second time, we will take and multiply this by a -3 and combine it with that one. So the first equation, or the bottom equation, will stay as 3x plus 2y plus 2z equals 46, and then a -3x plus 15y minus 6z equals a -126. And combining those, and that's 0, that would be 17y minus 4z equals a -80. So now then, completing this, we have two equations with two unknowns. This one here and that one there. And you can solve by elimination or substitution here as well. Doesn't matter which one you're going to do. We will choose to go the substitution route. We're going to solve this one for y. So you'd get 13y because you got to add 10z equals 10z minus 60. Divide by 13, and y is equal to 10 over 13z minus 60 over 13. This then must be substituted in for y into the other equation. So now you have 17 times 10/13 z minus 60/13 minus 4z equals a negative 80. Then distributing this to that and to that would be 170 over 13z minus, and now we have 60 over 13 times 17, which should be a negative 1020 over 13 minus 4z equals a negative 80. And finally, then we can combine the two z terms. So 170 over 13 minus 4 will give you 118 over 13z. And then we have to add 1020 over 13 to both sides. So a negative 80 plus 1020 over 13 is equal to a negative 20 over 13. Now then, to solve for z, you would multiply this by 13 over 118 on both sides. And that's going to turn into z equals, and let's see, 13's cancel out, and 2 goes into both of those, so a negative 10 over 59. So there is our z value. Substitute that now into this equation for z, and you have y equals 10/13 times a negative 10 over 59 minus 60 over 13. It's getting to be some work. So now we have a negative 100 over 767 minus 60 over 13. And so then if we have a negative 100 over 767 minus 60 over 13, we will get y equal to a negative 280 over 59. Hey, we're getting closer. Now we have to solve for x. And the equation that I want to use to solve for x is going to be this middle one. Because x is already by it, well, it's singular, not by itself, but x minus 5y plus 2z equals 42. So x minus 5y plus 2z equals 42. Is that correct? Hey, it is. All right, so now we substitute. And we have to put a negative 280 over 59 in for, so we got x minus 5 times a negative 280 over 59 plus 2 times negative 10 over 59 equals 42. Distributing 5 times 280, which would be a positive, so x plus 1400 over 59 minus 20 over 59 equals 42. Would you look at that? They have the same denominator, so then we just subtract. So we have x plus 1380 over 59 equals 42. And 42 minus 1380 over 59 is going to be, because we got to subtract 1380 over 59. And so then x is going to equal 1098 over 59. So x is that, y is this, and z is that. Now I'm not going to give you a question that's going to be massively that bad, but maybe. Anyway, you have a regular calculator, so you should be able to do all the math part of it. All right, so moving on. Final thing for this part of the review would be graphing and finding the feasible region. If you're going to graph x is greater than or equal to 0, that is a vertical line going through 0, and we're going to shade to the right. Graphing y equals a -1 is a horizontal line going through a -1, so that's down here. And we're going to shade above that one. So then move this up. Oh, come on. So we're shading up. All right, then going to the red one, subtract x, and you're going to get y is equal to a -x plus 10, less than or equal to, but you don't have to worry about that part of it. So we go up to 10, and then we're going down 1 and over 1. And there's that line. And now when you try to figure out the shading, here's where if you don't want to use this equation, go back to the original, substitute a coordinate, 0, 0. Is that a true statement? 0 is less than or equal to 10. It is true. So therefore we're going to go below that line. There we go. Yes. All right. And then finally, this equation, first subtract 2x. And you have 3y less than or equal to a -2x plus 21. Divide by 3. And y is a -2/3 x plus 7. So now we go up to 7. And then down 2 and over 3. Down 2 and over 3. Down 2 and over 3, down 2 and over 3, down 2 and over 3. Got that line going there. So then you put in a 0, substitute 0, 0 in again, and 0, 0, so 0 is less than or equal to 21. Hey, that's true as well, so we're shading below here as well. And so the region that we have would go from here to there, to there, to there, to there. So that means anything inside of that shaded area would work in all of these inequalities. Now then, we are asked to maximize this function, 2x minus 3y. Actually, not a function that, well, yeah, it is. Okay, so to maximize, they would occur at one of these vertices. This vertice is at 0, -1. And if you substitute a 0 and a -1 in for x and y, you will get an answer of 3. Next coordinate is this one up here, which is 0, 7. And when you substitute 0 and 7 in, you would get -21. When you substitute this coordinate in, this one is 1, 2, 3, 4, 5, 6, 7, 8, 2. So when you put an 8 there and a 2 there, you are going to get, hold on, did we do something wrong? Yeah, we did. That's a really bad drawing. Let me back up for a moment because I know that point is not supposed to be 8, 2. Let's get rid of this here for a moment. Okay, so this red one is coming down 1 over 1, so it's going right through there. And this one here is going down 2 and over 3 and down 2 and over 3. Right there is our coordinate. That looks better. So we kind of messed up. So here is where that coordinate should be. Not at 8, 2. Instead, it is at 9, 1. Still the same concept, just had a momentary lapse of not being in the right place. So if you put a 9 and a 1 in there, 18 minus 3 is 15. And then finally we have this coordinate down here, which is at 10, 11, -1. So if you put an 11 and a -1, you will get 25. And so you would then say the maximum occurs at 11, -1, and the maximum value is 25. If the question wanted to know what the minimum was, the minimum is this one here, 0 and 7, so this coordinate would be considered a minimum at 0, 7 with a minimum value of a -21. Now, those aren't always going to be the same. It all depends on what this objective function has for an equation. And that's pretty much everything that you will see on the first day test.